On the frozen edge of the solar system, where sunlight dwindles to a faint glimmer, Uranus drifts in silence, a pale blue giant cloaked in mystery. Its atmosphere, wrapped in layers of clouds, conceals secrets that have eluded us for centuries. Humanity's story with this enigmatic world has been written only in passing, fleeting encounters by robotic explorers racing through the dark. For nearly 40 years, our vision of Uranus has rested on a single snapshot, captured during Voyager 2's historic flyby. In 1986, as Voyager 2 hurtled past Uranus at more than 15 kilometers per second, it collected a treasure trove of data. Scientists were captivated by the planet's unique tilt, its faint rings and its moons. But what stood out most was the temperature. The numbers painted a picture of a planet that seemed almost eerily cold. Unlike its planetary neighbors, Uranus appeared to emit almost no internal heat. To astronomers, this was a cosmic puzzle. While Jupiter and Neptune radiated far more energy than they received from the Sun, Uranus seemed to be in a deep freeze, its internal fires long extinguished. But the cosmos never ceases to surprise us. Now, almost 4 decades later, new research has shaken the very foundation of what we thought we knew about Uranus. Scientists at the University of Houston, piecing together decades of observations, have discovered that Voyager 2's readings may not have told the full story. Using a combination of data from various spacecraft and advanced computer modeling, they've uncovered evidence that Uranus is actually glowing with more heat than previously thought. 12.5% more than it receives from the distant Sun. It's a subtle warmth, far less than the infernos of Jupiter or Neptune, but significant enough to rewrite textbooks. What does this mean for our cosmic neighbor? It suggests that Uranus is still slowly venting the heat left over from its violent birth 4.5 billion years ago. Deep within, beneath layers of icy hydrogen and helium, the planet's interior is not as dormant as we once believed. This gentle leakage of ancient heat is a vital clue, a key to unlocking the story of how Uranus formed, how it has changed over eons, and what makes it so unique among the planets of our solar system. But how could such a fundamental fact have slipped through the cracks? The answer may lie in the timing of Voyager 2's flyby. It's now thought that the spacecraft's instruments may have captured Uranus during an unusual bout of solar activity, a rare confluence that skewed the heat readings and left scientists with an incomplete picture. As new generations of astronomers revisit the data, combining it with modern observations and powerful simulations, the veil over Uranus is beginning to lift. This discovery has far-reaching implications. Understanding how Uranus stores and loses heat doesn't just help us piece together the planet's history. It offers a window into the fundamental processes that shape planetary atmospheres and weather systems across the cosmos. The same physics that governs the gentle glow escaping Uranus's core can inform our understanding of climate and weather on worlds both near and far. It may even help us refine our models of Earth's own atmosphere, providing new perspectives on the forces that drive our climate. The renewed interest in Uranus is more than just academic curiosity. For years, planetary scientists have called for a dedicated mission to this remote ice giant, a new generation of spacecraft to orbit, probe, and study Uranus up close. The latest findings reinforce the urgency of that mission. With a clearer picture of Uranus's internal dynamics, future explorers will be better equipped to design instruments, select targets, and plan daring dives into its mysterious atmosphere. Each new discovery adds another piece to the puzzle, sharpening our focus and fueling the drive to return to this enigmatic world. But the implications don't end at Uranus's cloud tops. The methods developed by the University of Houston team, combining long-term observations with cutting-edge computational models, can be applied to other planets, both within our solar system and beyond. As we discover more exoplanets orbiting distant stars, many with temperatures and compositions similar to Uranus, these techniques will become invaluable in unraveling their mysteries. The echoes of Uranus's heat signature may one day help us decode the atmospheres of entirely new worlds, light years from home. Light years from home. All this from a planet once dismissed as cold and lifeless. Uranus, it seems, still has much to teach us about the birth of worlds, the persistence of ancient heat, and the restless forces that shape the cosmos. The story of Uranus is far from over. Each new discovery draws us closer to the heart of this pale blue enigma as we continue our quest to understand the dynamic, ever-changing universe we call home. But just when we thought we understood Uranus, a planet that for decades seemed to defy expectations, new research has upended one of the longest-held beliefs about its mysterious interior. For nearly 40 years, Voyager 2's brief encounter with Uranus defined our understanding of its heat budget. Those fleeting hours in January 1986 painted a picture of a world eerily cold and seemingly inert, radiating almost no heat of its own. It was a cosmic oddity, standing apart from planets like Jupiter and Neptune, both of which blaze with the lingering warmth of their ancient formation. Uranus, it seemed, had lost all memory of its fiery birth. But science thrives on challenging assumptions. Now, a new study led by researchers at the University of Houston has pulled back the curtain once again, revealing that Uranus may be far more dynamic than Voyager ever hinted. By meticulously combining 4 decades of planetary observations, spacecraft data, and advanced computer modeling, the team has unearthed a surprising fact. Uranus actually emits about 12.5% more heat than it receives from the distant Sun. This discovery is more than just a numerical revision. It fundamentally reshapes our picture of Uranus's interior. Rather than a planet that lost its primordial heat to the void, Uranus appears to be slowly venting energy left over from its tumultuous formation. This slow leak of ancient warmth is a tantalizing clue, hinting at hidden processes deep beneath its pale blue clouds. It suggests that Uranus, like its planetary siblings, is still evolving, still changing, and still holding secrets about the early days of our solar system. The implications of this revelation ripple outward. If Uranus is still releasing internal heat, what mechanisms are at play within its mysterious core and mantle? Is there a sluggish churning of exotic ices and gases, a slow migration of energy that shapes its magnetic field and drives unexpected weather patterns? Or does its unique history, a dramatic sideways tilt, perhaps the aftermath of a colossal collision, mean that Uranus's interior moves in ways unlike any other planet we know? One possible reason Voyager 2 missed this subtle heat signature lies in the timing of its historic flyby. The spacecraft's instruments captured Uranus during a rare window of solar activity, a cosmic coincidence that may have masked the planet's ordinary heat emissions. This revelation is a powerful reminder that in planetary science, context matters. Every observation is but a snapshot, and a planet's true nature can only be revealed through patient, persistent study across many years and multiple missions. The new findings have fired imaginations across the astronomical community, reigniting calls for a dedicated mission to Uranus. After all, Voyager 2's legacy is both inspiring and incomplete. Its instruments were designed for quick flybys, not prolonged studies. Today's scientists are eager to send an orbiter equipped with the latest tools, thermal imagers, spectrometers, and magnetometers, to linger in Uranus's orbit, mapping its temperature in exquisite detail and probing the depths of its atmosphere. A future Uranus mission would do more than solve the riddle of its heat. It could unlock a treasure trove of insights about planetary evolution throughout the cosmos. Many exoplanets discovered so far are ice giants, worlds that, from a distance, resemble Uranus and Neptune more than any other planets in our solar system. By decoding Uranus's secrets, we sharpen our tools for studying these distant worlds, learning how atmospheres form, how heat shapes weather, and how planets change over billions of years. And the impact isn't limited to worlds beyond our own. The methods pioneered in this study, painstakingly integrating data from multiple missions, refining computer models to match new observations, offer a blueprint for understanding Earth's own climate system. By observing how Uranus stores and releases heat, scientists gain a broader perspective on the fundamental processes that govern planetary atmospheres, from the icy giants at the edge of our solar system to the delicate balance that sustains life here on Earth. As we look back on 40 years of exploration, from Voyager's historic passage to the cutting-edge research of today, one thing becomes clear. Uranus is not a static relic, but a living world, evolving before our eyes. Each new discovery challenges us to rethink what we know, to question old assumptions, and to push the boundaries of our knowledge ever further. The more we learn about Uranus, the more we realize how much remains hidden, locked beneath clouds of methane, waiting for the next generation of explorers to reveal. The case for returning to Uranus grows stronger with every new insight. A dedicated orbiter could map its complex magnetic field, study the shifting patterns of its clouds, and, perhaps most intriguingly, trace the faint glow of internal heat escaping into the void. It could search for signs of hidden storms, probe the structure of its rings, and even hunt for potential moons we have yet to discover. With each measurement, we would not only deepen our understanding of Uranus, but also gather clues about the birth and evolution of planets across the galaxy. In the grand tapestry of the solar system, Uranus has always been a world apart, a place of serene blue hues and silent storms, spinning on its side as it drifts through the darkness. But now, thanks to decades of observation and the relentless curiosity of scientists, this ice giant is stepping into the spotlight. Its secrets are ours to uncover, its mysteries ours to solve. And as we prepare for the next era of exploration, Uranus stands as a testament to the power of discovery, reminding us that even the most distant worlds can surprise us, challenge us, and inspire us to reach farther than ever before. Today, as we look back on nearly 4 decades since Voyager 2's historic flyby, we find ourselves standing at the threshold of a new understanding. The data beamed back in 1986 shaped our expectations of Uranus. A world frigid and quiet, apparently radiating little to no heat from within. But recent studies have rewritten this narrative, revealing a planet still echoing with the warmth of its ancient past. In a groundbreaking project led by researchers at the University of Houston, scientists meticulously analyzed decades of observational data. By weaving together information from multiple spacecraft, ground-based telescopes, and advanced computer simulations, they've discovered that Uranus emits about 12.5% more heat than it receives from the Sun. This is a subtle, almost ghostly warmth, but it's enough to challenge long-standing theories about the planet's interior and evolution. This new measurement is crucial. It suggests that Uranus is not a cold, inert sphere, but a planet still cooling off from its formation, slowly radiating the residual heat left over from its turbulent birth billions of years ago. Unlike Jupiter and Neptune, whose intense internal heat powers dynamic weather and vivid cloud bands, Uranus's heat signature is faint, yet unmistakable. The fact that it emits more energy than it absorbs changes our understanding of its interior, hinting at a complex structure of ices, fluids, and perhaps even hidden layers of convective activity. Why did Voyager 2 miss this internal glow? The answer may lie in the timing of its encounter. The spacecraft's instruments captured Uranus during a rare phase of solar activity, when the Sun's influence may have temporarily masked the planet's subtle heat signature. With only a brief window to observe, even the most sophisticated instruments can be fooled by cosmic coincidences. Now, with fresh data and the power of modern computing, scientists can peer beyond those fleeting moments. The realization that Uranus is still venting primordial heat opens up exciting questions about its internal dynamics. Is there an ocean of supercooled water and ammonia sloshing beneath its cloud tops? Could there be layers of exotic ices, squeezed by pressure into unfamiliar forms? each answer brings us closer to understanding not just Uranus, but the processes that shaped all giant planets, including those orbiting distant stars. These revelations also fuel the growing momentum for a dedicated mission to Uranus. As researchers like Professor Liming Li have pointed out, every new piece of information helps refine our plans, guiding engineers and mission planners as they design instruments capable of unraveling the planet's deepest mysteries. A future probe could map the thermal structure of Uranus, measure its winds and weather, and perhaps even deploy atmospheric entry vehicles to sample its exotic gases firsthand. And the implications extend far beyond Uranus itself. The methods developed to tease out its internal heat will help astronomers study other worlds, from Neptune to exoplanets light years away. Understanding how planets store and release energy is fundamental to deciphering the evolution of atmospheres, the formation of clouds and storms, and the possibility of habitability. Even here on Earth, these discoveries enrich our perspective, reminding us that our world is part of a vast, interconnected system of planetary science. The saga of Uranus is a testament to the enduring spirit of exploration. Each new observation, each recalibrated model, each carefully scrutinized dataset brings us closer to the truth. The story is not just about one distant planet, it's about the power of curiosity, the relentless pursuit of knowledge, and the extraordinary tools we have built to answer questions that once seemed beyond our reach. As we look to the future, the call for a new mission to Uranus grows louder. With modern spacecraft, we could spend years in orbit, watching the seasons unfold, probing the depths of its atmosphere, and perhaps even catching a glimpse of the forces that tipped this strange world onto its side. The mysteries of Uranus remind us that the solar system is far from fully explored and that every answer uncovers new questions waiting in the dark. Thank you for joining us on this journey to the edge of the unknown. If you're as fascinated by the wonders of our universe as we are, make sure to like this video and subscribe for more content like this. The adventure is just beginning, and there are countless worlds left to explore. And the implications extend far beyond Uranus itself. The methods developed to tease out its internal heat will help astronomers study other worlds, from Neptune to exoplanets light years away. Understanding how planets store and release energy is fundamental to deciphering the evolution of atmospheres, the formation of clouds and storms, and the possibility of habitability. Even here on Earth, these discoveries enrich our perspective, reminding us that our world is part of a vast, interconnected system of planetary science. The saga of Uranus is a testament to the enduring spirit of exploration. Each new observation, each recalibrated model, each carefully scrutinized dataset brings us closer to the truth. The story is not just about one distant planet, it's about the power of curiosity, the relentless pursuit of knowledge, and the extraordinary tools we have built to answer questions that once seemed beyond our reach. As we look to the future, the call for a new mission to Uranus grows louder. With modern spacecraft, we could spend years in orbit, watching the seasons unfold, probing the depths of its atmosphere, and perhaps even catching a glimpse of the forces that tipped this strange world onto its side. The mysteries of Uranus remind us that the solar system is far from fully explored and that every answer uncovers new questions waiting in the dark. Thank you for joining us on this journey to the edge of the unknown. If you're as fascinated by the wonders of our universe as we are, make sure to like this video and subscribe for more content like this. The adventure is just beginning, and there are countless worlds left to explore.